Use the extension of the power rule to explore tangent lines. Alright, so in this video we're going to be talking about derivatives and how they relate to equations of tangent lines, or more specifically, how do we find the equation of a tangent line using derivatives. Alright, so first we just need to do a little bit of review here. We need to review what the equation of a linear line is. And again, we need to review this because a linear line is also our tangent line. Alright, so if you remember way back to when you first learned about linear lines, you were told that there are multiple different forms of a linear line, and each came with their own specific formula. Now, the most common one that is used is the slope-intercept form. And this particular equation is the standard linear function, y equals mx plus b. Now, what do we need in order to use this particular form of linear line? Well, fortunately, it's right in the name. Since this is the slope-intercept form, we're going to need to figure out what the slope is, and then we're going to need to figure out the y-intercept. Another formula that's important is the point slope form of a linear line, and this equation is y minus y sub 0 is equal to m times x minus x sub 0. And just like with the slope-intercept form, what we need is in the name. So we can see that we're going to need a point, x sub 0 comma y sub 0, and we're going to need the slope m. Now, depending on what the problem gives us is going to depend on which forms of the linear equations we are going to use, so let's dive in and take a look. So in our first example, we want to find the equation of the tangent line to the graph of the function f of x is equal to x minus 5 over x at x equals 2. So we are trying to find the equation of the tangent line. So we can start out with that equation. Personally, I like to start out with the point slope form, and hopefully you will see why as we work through this problem. But if you'd like to start out with the slope-intercept form, that is 100% fine as well. But our point slope formula is y minus y sub 0 is equal to m times x minus x sub 0. Now, as we said, we're going to need to know two pieces of information. We're going to need to know the slope, and we're going to need to know a point. So let's just work on the side here. A little bit of scratch work on the side. And let's find the slope. Well, we know that we can find the slope of a curved line by finding the derivative. So that means we're going to have to go ahead and we're going to have to find the derivative of x minus 5 over x. But before we do that, we need to rewrite this a little bit because we have not learned the quotient rule yet, so we don't know how to take the derivative of a fraction that has a variable in the denominator. But fortunately, we can rewrite it, so we know this is going to equal x minus 5 times x to the negative first power. And again, all we did here was we just rewrote it. We have not taken the derivative yet. That's our next step. So we can take the derivative. Let's see, the derivative of x is just going to be 1. The derivative of negative 5 times x to the negative first power. Well, let's remember, power rule says we take the exponent, multiply it by the coefficient, and then subtract 1 from the original exponent, which is going to give us a positive 5 times x to the negative second power. Alright, then we can rewrite this to get rid of that negative exponent to be 1 plus 5 over x squared. Now we have the derivative, which means we can find the slope at any point on the function x minus 5 over x. But we don't want to find it at any point, we want to find it at the point where x equals 2. So that means we need to solve for f prime of 2, so we can go ahead and we can plug this in. So we're going to get 1 plus 5 over 2 squared, which can be simplified to be 1 plus 5 over 4, which will end up being 9/4 as our slope. Alright, so we have our equation of a tangent line in the middle here. Y minus y sub 0 is equal to m times x minus x sub 0. So now we can plug in the slope, which is going to be 9/4. And we can bring down some other pieces. This is going to be y minus whatever y sub 0 is times x minus whatever x sub 0 is. Which means next up we need to find the point, the second piece of our point slope form. Now we are looking for an x sub 0 and a y sub 0, and the problem tells us that our x sub 0 is going to be 2. Now how do we find the y sub 0? Well, remember the y is the output of x. So all we need to do to find our y sub 0 is substitute in f sub 0 into our function. So that means y sub 0 is going to be, let's see, x, which is 2, minus 5 over x, which is 2. So let's see, 2 minus 5 halves. If you're uncertain of how to do this, the calculator is your best friend here. You can go ahead and you can plug it in. And when you plug in 2 minus 5 halves, you're going to get an answer of negative 1 half, which means we're going to be trying to find the equation with a tangent line at the point 2 comma negative 1 half. So we can plug these values in. Y sub 0 is negative 1 half, and x sub 0 we know is 2. And then we can simplify this down a little bit to get y plus 1 half is equal to 9/4 times x minus 2. Now this is a 100% perfect equation for the tangent line here. However, sometimes Newton questions like you to write this in slope-intercept form. So let's talk about how we can do that. Remember, slope-intercept form, we have the y by itself, and we need to be in the form y equals mx plus b. So first let's go ahead and let's solve for y. So we can subtract 1 half from both sides. And that's going to leave us with y is equal to 9/4 times the quantity x minus 2 minus 1 half. Alright, so we have the y by itself, but it's not quite in that form yet. So we can take the 9/4 and we can distribute it through, which is going to give us y is equal to 9/4 x minus 18/4 minus 1 half. And again, if you're not good with fractions, please go ahead, use the calculator. That's why we have it. And throw the fractions in there. And we're eventually going to be able to simplify this down to be y equals negative 9/4 x minus 9/4 as our equation of the tangent line in slope-intercept form. So again, please make sure you read the directions clearly in Newton, because Newton's going to tell you what form it wants the equation of the tangent line in. And I just realized I made a boo-boo. I don't know where that negative 9/4 came from. Sorry about that. This should be a positive 9/4. So y is equal to positive 9/4 x minus 9/4. Super easy to make little tiny mistakes that just mess up everything. So it happens. Alright, so same thing. We want to find the equation of the tangent line to the graph of the function f of x is equal to 5x minus 3x to the 2/3 power, and this time at x equals 8. So we'll do the same thing as we did before. We will start out with our equation of the tangent line. Again, I like to start out with the point-slope form. It just makes it easy to plug all of our information in and then convert it to y equals mx plus b. Alright, so again, let's just do some scrap work on the side here to find the slope. And then to find the slope, we just need to find the derivative. We can go ahead and we can take the derivative of 5x minus 3x to the 3/2 power. Let's see, derivative of 5x is just going to be 5. Then minus, we're going to take the 2/3, multiply it by 3, subtract 1 from the original exponent. So that's going to give us what? Negative 2x to the negative 1/3 power. Alright, so since we are eventually going to have to find the slope at x equals 8, we are going to want to first get rid of this negative exponent. So let's go ahead and let's just quickly rewrite this. This is going to be 5 minus 2 over x to the 1/3 power. And now when we do plug in 8, well, 8 to the 1/3 power is not very obvious. So let's change that 1/3 power back into a radical, which means our derivative will be 5 minus 2 over the cube root of x. And then from here we can substitute in the 8 for x, giving us 5 minus 2 over the cube root of 8. Well, the cube root of 8 is going to be 2. 2 divided by 2 is going to be 1, and 5 minus 1 is going to be 4. So we know our slope is going to be 4. And then next up we need to find the point. And the problem already tells us that x sub 0 is going to be 8. And we know to find y sub 0, we just need to plug our x sub 0 into our function. So into the 5x minus 3x to the 2/3 power. So let's go ahead and do that. So that's going to be 5 times 8 minus 3 times 8 to the 2/3 power. Now you might be thinking to yourself, I have no idea what 8 to the 2/3 power is. And that's fine. You can always convert the 2/3 power into a radical and then simplify, or just plug it right into your calculator, 8 raised to the 2/3 power. And when we do that, we're going to get 4. So let's see, we're going to get 5 times 8, which is 40, minus 3 times, we just said 8 to the 2/3 power is 4. Whoa. 40 minus 3 times 4. And let's see, this is going to be 40 minus 12, which is going to be 28. So that means we're going to be dealing with the point 8 comma 28. And let's go ahead and plug in everything we know. So we're going to have y minus, we just found out that y sub 0 is 28, is equal to, we know the slope is going to be 4, and that's times x minus x sub 0 is 8. And again, this is a perfectly acceptable answer. If you are allowed to leave your answer in point slope form, you would be done. But if not, we need to convert it to y equals mx plus b, slope intercept form. And the first thing we can do is we can add 28 to both sides, which is going to give us y is equal to 4 times the quantity x minus 8 plus 28. From here we can take the 4 and we can distribute it in, which is going to give us y is equal to 4x minus 32 plus 28. And then we can combine like terms to get 4x minus 4 as the equation of our tangent line in slope-intercept form. Our next example is a little different because this time, in addition to finding the tangent line, it's also asking us to graph the tangent line. So let's go ahead and let's get started. Since we do want to find the tangent line to begin with, we can repeat the process we've been doing in the last couple examples. We're going to start with our equation, y minus y sub 0 is equal to m times x minus x sub 0. And we'll do a little bit of work on the sides. And first off, we're going to find the slope. Now, unfortunately, in order to find the slope, we do have to get rid of the square root. So we can rewrite our function to be f of x is equal to 4x to the 1/2 minus 1. And now from here we can take the derivative, so f prime of x is going to be, let's see, 1/2 times 4 is 2, x to the negative 1/2 power, and the derivative of negative 1 is just 0. So therefore the derivative is 2x to the negative first power. We are going to want to plug in 9 next, but before we do, we want to be able to plug in 9 to a function we can actually evaluate, not something to a negative 1/2 radical. So let's continue simplifying this. So I can get rid of the negative by moving the x to the 1/2 to the denominator. And I can get rid of the 1/2 fraction by changing it back into a radical. So therefore the derivative is going to be 2 times the square root of x. Now we can plug in the x value of 9 to get 2 over radical 9, which will give us a slope of 2/3. Now we do need to find that point. And we can see here that x sub 0 is going to be 9 because that's what the problem gave us. And what happened there? Big old line. Let's try that again. So x sub 0 is equal to 9 because that's what the problem gave us. And then to find y sub 0, we just need to plug our x into our function. So that's going to give us 4 times the square root of 9 minus 1. So that'll be 4 times 3 minus 1, which will give us 11. So that means we're going to be looking at the point 9 comma 11. All right, so now if we plug these equations in, if we plug the slope and the point in, we're going to get y minus 11 is equal to 2/3 times x minus 9. All right, then we can go ahead and we can turn this into slope-intercept form by adding 11 to both sides to get y is equal to 2/3 times x minus 9 plus 11. And then we can distribute the 2/3 in to continue to simplify. So this is going to give us y is equal to 2/3 x minus 2 times 9 is 18. 18 divided by 3 is 6, plus 11, or y is equal to 2/3 x plus 5. All right, so now that we have the equation of the tangent line, we just need to graph it. And let's see, we know that the point on the curve we're trying to draw the tangent line through is 9, 11. So we can go ahead and put that point in here. Now we need to graph the tangent line. Well, we can see the tangent line is going to have a slope of 2/3. So there we can use our typical rise over run formula to plot another couple points and then draw the line through it. So let's see, we're going to go up 2, and then we're going to go over 3 to get to this point right here. And then we can do that, actually it doesn't look like we can do that because we ran out of graph, but we can do the opposite direction, meaning we can go down 2 and back. 1, 2, 3, which puts our second point there. And then we can come in and we can actually sketch the tangent line. And there you have it. And this line is going to be y is equal to 2/3 x plus 5 as our graphed tangent line. And then finally, this one's also a little bit different. We want to find the values of where, we want to find the values of x where the tangent line to the graph of the function f of x is equal to 5x minus 2 over x is parallel to the line y equals negative 3x minus 11. You might be thinking to yourself, how do we do this? We want to find parallel lines? And yes, we want to find a parallel line. But what do we know about parallel lines? Let's see if you remember back from one of your algebra classes. If we remember, parallel lines have the same slope. Meaning, the slope of this equation, y equals negative 3x minus 11, is going to be the same somewhere on this particular function. We just need to figure out the x values where. Well, so to begin, we should probably find the slope of this linear line. And we can see here the slope of this linear line is negative 3. All right, great. So that's done there. Now we're going to have to find the slope of this function. And to find the slope of that function, we're going to have to take the derivative. But before we do that, we need to get the x out of the denominator. So we'll just rewrite our function before we take the derivative. So our function will be f of x is equal to 5x minus 2x to the negative first power. Then we can take the derivative, which is going to be 5 plus 2x to the negative second power, which we can rewrite as 5 plus 2 over x squared. All right, so now we have the derivative of both of our functions, but again, we know that derivatives, which represent slope, have to be the same. So we can just take these two slopes and set them equal to each other. And that will give us the x values, where these two functions have the same slope. All right, so to begin with, I'm going to subtract 5 from both sides to help get the x by itself. And that's going to leave us with 2 over x squared is equal to negative 8. Well, then I'm going to multiply both sides by x squared to get it out of the denominator. Boom, 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 done. Which is going to leave us with 2 is equal to negative 8x squared. And then I can come in here and I can divide both sides by negative 8. And I've run out of room, so let's continue over here. This is going to give us negative 1/4 is equal to x squared. All right, so we can continue solving for x, and we can do that by taking the square root of both sides. And here's where we run into a problem. Yes, we can take the square root of a negative number. It's going to be a complex number. But in calculus, we're only dealing with real numbers. So therefore, we're not going to be able to find an x value. So what does that mean? Well, in that particular problem, that means there are no x values where the lines are parallel. Now, when you try this in Newton, you should be getting an actual numerical value here and plugging it in, but every now and then I like to throw a curveball. I didn't want you to get tripped up on that one when you solve the problem, because sometimes it is possible that there just isn't a parallel tangent line. All right, folks, that is it. That is using the extension of the power rule to explore tangent lines.